This is our nuclear chemistry project on nuclear medicine and diagnosis, made by Hagar, Eva, Jolie, and Frederick. Hope you enjoy! The use of radiation and radioisotopes are the main medical treatments that cause nuclear chemistry to occur while diagnosing illness. Ionizing radiation is the form of radiation that has the potential to cause cancers, damage cells, and knock electrons out of atoms. When this happens, the nucleus has the potential to become unstable, which can result in a radioactive decay. This involves nuclear reactions and radioactive decay. Radioisotopes are attributes of naturally decaying atoms. The natural decaying atoms requires nuclear reactions. The main purpose of using radiation and radioisotopes in our world is to diagnose patients with cancer, treat cancers, and prolong the cancer patient's life. Both radiation and radioisotopes are emitted during medical scans and screenings.
Nuclear applications in nuclear medicine diagnosis. Radio tracers. Radio tracers are chemical compounds where one or more atoms are replaced by a radioisotope. Radioisotopes. Radioisotopes are basically radioactive isotopes, or atoms with an unstable nucleus. Examples of radioisotopes are iodine-131, technetium-99m, and chromium-51. How they are used. They are injected into the bloodstream, swallowed, or inhaled. They concentrate at the area of your body being looked at. There, they give off energy in the form of gamma rays. Cameras detect the energy and create images that offer details on the structure/functions of organs and tissues.
The history of nuclear medicine diagnosis. In 1924, the first radio tracer study on animals was done by scientists Georg de Hevesy, J. A. Christiansen, and Sven Lumholt using lead-210 and bismuth-210. In 1939, the first paper was published on the diagnostic uses of iodine-131 by Joseph Gilbert Hamilton, Mayo Soley, and Robley Evans. In 1949, phosphorus-32 and a probe detector were used to detect brain tumors by B. Silverstone. In 1950, human serum albumin with iodine-131 was used to image the blood pool in the heart by K. R. Crispell and John B. Stralsey. In 1955, rose bengal with iodine-131 was used to image the liver, and scintillation detectors with radioiodinated heparin was used to measure the function of the kidney by George V. Taplin. In 1957, xenon-133 was used to measure the ventilation of lungs by H. Knipping. In 1958, scintillation camera was invented by Hall Anger. It is a device that can be used to perform many studies using imaging. In 1959, radioimmunoassay was invented by Solomon Burson and Rosalind Yellow to observe insulin antibodies in a sample of human serum. In 1962, emission reconstruction tomography, later known as SPECT and PET, was introduced by David Kuhl. In 1964, the radio tracers TC99M started being used to study the brain, thyroid, and liver by Paul Harper and Catherine Lothrop. In 1968, xenon-133 ventilation scans were used to diagnose pulmonary embolism by Henry Wagner and his colleagues. In 1971, phosphates with TC99M were used for imaging of bones by Gopal Subramanian and John McAfee. In 1973, thallium-201 was introduced for imaging of myocardial perfusion by Elliot Lebowitz, inspired by the proposal of Kawana. In 1976, the first SPECT camera was developed by John Caius, and the first dedicated head of a SPECT camera was developed by Ronald Zasak. In 1977, the FDA approval was granted to New England Nuclear for the distribution of thallium-201 for diagnosing and locating of myocardial infarction. In 1983, the first SPECT image of a neuroreceptor successfully taken by William Eckelman and Richard Reba. In 1988, FDA approved brain perfusion radiopharmaceutical with TC99M to diagnose strokes, which was introduced by Amersham. In 1994, the FDA approval was given to Mallinckrodt for peptide radiopharmaceutical to image granulomas and autoimmune diseases. In 1997, 123 I-beta-CIT was used to examine dopamine transporters in order to diagnose Parkinson's disease. In 1999, the HCFA approved sentinel node studies to improve cancer diagnosis and detection. In 2004, the PET Center of Excellence was granted permission to advance diagnostic nuclear medicine procedures. In 2007, Molecular Imaging Center of Excellence is founded in order to use molecular imaging to diagnose, detect, and treat all sorts of diseases. In 2008, the fusion of PET and CT scans spread widely and provided more understanding of the underlying causes of many diseases.
We are for using nuclear chemistry as a way to diagnose. Why? The benefits are very high yield, including providing unique information on your body systems, identifying early disease before symptoms show, and being cheap and simple. Although there are health risks to using nuclear chemistry involving radiation exposure, the result is worth it in the end.
So basically, these are our sources: chemistry for non-majors, a historical timeline of chemistry in the medical world, radioisotopes in medicine, nuclear medicine in general, and what is nuclear medicine.